the beginning of everything. The Big Bang. Up to the middle of the 20th century, most scientists thought of the universe as infinite and ageless.
Until Einstein's theory of relativity gave us a better understanding of gravity.
And Edwin Hubble discovered that galaxies are moving apart from one another in a way that fits previous predictions.
In 1964, by accident, cosmic background radiation was discovered, a relic of the early universe.
Which, together with other observational evidence, made the Big Bang the accepted theory in science.
Recent observations even seem to suggest that the expansion of the universe is accelerating.
But how did this Big Bang work? How can something come from nothing?
Let's explore what we know.
We can ignore the beginning part for now.
First of all, the Big Bang was not an explosion.
It was all space stretching everywhere all at once.
And quickly expanded to the size of a football.
The universe didn't expand into anything. Space was just expanding into itself.
There is, by definition, no outside the universe. The universe is all there is.
In this hot, dense environment, energy manifested itself in particles that existed only for the tiniest glimpses of time.
From gluons, pairs of quarks were created, which destroyed one another, perhaps after giving off more gluons.
These found other short-lived quarks to interact with, forming new quark pairs and gluons again.
Matter and energy were not just theoretically equivalent. It was so hot they were practically the same stuff.
Somewhere around this time, matter won over antimatter. Today, we're left with almost all matter and nearly no antimatter at all.
Instead of one massive ultimate force in the universe, there were now several refined versions of it, acting under different rules.
By now, the universe has stretched to 1 billion kilometers in diameter, which leads to a decrease in temperature.
The cycle of quarks being born and converted back to energy suddenly stops.
From now on, we work with what we have.
Quarks begin forming new particles, hadrons, like protons and neutrons.
There are many combinations of quarks that can form all sorts of hadrons.
Many hadrons formed, but only a few stayed stable long enough to survive.
And remember, only 1 second has passed since the beginning of everything.
As the universe grew and cooled, most neutrons decayed into protons.
This allowed the first atom to form, hydrogen.
At this stage, the universe was a burning hot soup of particles and energy.
Over the next few minutes, everything cooled and settled down fast.
atoms formed, creating a stable and electrically neutral universe.
Some call this period the Dark Age, because there were no stars.
And thick hydrogen gas didn't allow visible light to move freely.
But what's the meaning of visible light?
After millions of years, hydrogen clumped together as gravity pulled it tighter.
Under great pressure, the first stars and galaxies began to form.
Their radiation dissolved stable hydrogen into plasma, changing the universe forever. And for the first time, visible light could finally travel freely. Finally, there was light. What happened? This part can be defined as the Big Bang.
At this point, our tools break down.
Natural laws stop making sense.
To understand this, we need a theory that unifies relativity and quantum mechanics.
What started the Big Bang? Or did it happen naturally, by laws we don't understand yet? We don't know. And maybe we never will. But we do know this: the universe as we know it started here. It gave birth to particles. It gave birth to galaxies. It gave birth to stars. It gave birth to the Earth. Because we are made of dead stars, we are not separate from the universe. We are part of it. Until there are no more questions to ask.